Hello. At the end of the last video, I forgot to show you this slide. I wanted to show you this. So, like, this is another experiment. I changed it. I fixed the probability of success at 0.5, but I changed the number of coin toss. How many times you toss a coin, and then we count the number of heads. So when you throw 5 coins, then the number of heads can be at minimum 0, of course, and at most 5, of course, right? So there are 6 different values, 0, 1, 2, 3, 4, 5, right? So distribution looks like this. And when you increase the number of coins to 10, it ranges from 0 to 10, even though you cannot see the probability at 0 and 10 because they are extremely small, but there is a very small probability there. So 0 to 10 is the range, 11 different values. And it is symmetric because probability is 50%, but what changes from 5 to 10 is the range. The range extends at first 0 to 5 and then 0 to 10, and then when you increase the number of coins to 20, then the range will be 0 to 20. So the range depends only on the number of experiments n, this n parameter n, right? And then the n determines the range, and p determines the skewness, whether it is symmetric or skewed. So skewed to left, skewed to right, skewed to right. So right side tail is longer and left side tail is longer, and both sides have same tails. So P determines, probability determines the location, tendency, and N determines the range. So that's the basic roles of those parameters, how the parameters determine the shape. And okay, then let me show you how to calculate the probability on Excel. So first, I will give you an example. Let's consider tossing 20 coins, and Y is the number of heads, as I explained. So we are interested in how many heads we get. So for example, let's calculate probability of Y equals, say, 5. Then the first thing you have to do here is, so we need to do two things. First, we need to count the number of different combinations. Choosing 5 out of 20. That is the first part. And second, the probability of a single outcome, right? So remember, this is how we derive the probability. So first, the combination. I'm going to show you. Combination function formula is given by this, combin, combine. So it returns the combination. So if you click this, what we are going to do is, we know 5 coins have heads and the other like 5 coins are heads out of 20. So you are choosing 5 out of 20, right? So here it explains what it is. Number is the total number of items, and number chosen is the number of items in each combination, right? So like out of 20 toppings, you are choosing 5 toppings, or out of 20 cards, you get 5, or out of 20 coins, you see heads for 5 coins. And the answer is this. This is the result from the first one. the number of different combinations. It's huge, right? It's what it is, like more than 15,000. So you cannot do it by hand. Of course, you need a calculator or Excel to calculate this. And now for the second part. For the second part, we would like to calculate the probability of a single outcome, which means we are going to multiply the probability of success as many times as the number of successes, in this case, number of heads, and also we are going to multiply the probability of tails as many times as tails happen. In this case, probability of head is 0.5, 50%, if the coin is fair, and it happened 5 times, right? And then tails, probability of tails is also 50%, and that happens 15 times. So this is a 0.5. The first 0.5 is probability of head, and the second 0.5 is the probability of tail. So the head happened 5 times, tails happened 15 times. If you calculate that, it's a super small number. So I will change it to a number, and then I will show you the decimals. It is this. So really small number, 0.00000095 something. So each outcome, a single outcome, takes really small probability because there are too many possible outcomes. So when you throw 20 coins, then how many combinations you get? That is 2 to the exponent of 20, which is a huge number. So a single outcome will be has a very small probability. However, if you multiply them at the end to get the final probability is multiplication of these two parts, then the final probability is this. It is like 1.4% if you change it to percentage and extend it. So this is the probability. So when you throw 20 coins, and then you will see 5 heads with the probability of 1.4786%. That's how we calculate the probability on Excel. So this is exactly what we did, and I just wanted to demonstrate how you utilize the formula on Excel. And actually, there is an easier way to implement this. That is, so there is a binomial distribution formula built-in formula. So that is binom.dist, binomial distribution. So binomial distribution formula, click this, then you have to enter many numbers. First number is number on the bar S is the number of successes in trial. So we are interested in 5 heads. So head is a success, and we are considering 5 heads. And the trials, the number of independent trials, 20. We are throwing 20 coins. So a single coin is 1 experiment. So we are looking at the probability of 5 heads out of 20 trials. So you have to put 5, read this part, and read this part, and then you will see what's the correct number. And probability of success is the probability of success, 50%. And cumulative. This question is asking you if you are interested in the cumulative probability or not. At this point, no. We are not looking at the cumulative probability. Remember, cumulative probability is the probability accumulated from 0. So when we put 5, this cumulative probability is the probability smaller than 5 or 5 or smaller than 5. But we are not considering cumulative probability, so it's false. So you have to put either true or false, but we are using false. And then if you calculate that, exactly the same number, right? So what we did in here is what you get using the formula. So it does not matter whatever you use, but it's up to you, whatever you prefer. And doing this way, if you change those numbers, of course the probability will change. But this is how I made up those graphs. Okay, then I'm going to stop here, and in the next video, we will study what is the mean and the variance of binomial distribution. Okay, see you there. Bye.